Hello, this is the luckiest maths teacher in the world. Today we'll look at operations with algebraic terms and also expanding brackets. So remember, a term is just a sequence of letters or numbers. So something like, 7a is a term. Something like 7a plus 3 is an expression, and both of these are terms. So we're going to look at doing operations with them, adding, subtracting them, and the like. So let's start off by looking at adding and subtracting. Now hopefully you remember you can only add or subtract if they're like terms. So remember, like terms is where they have the same sequence of pronumerals. So we'll go ahead and have a quick review of some like terms. So let's look at examples of like terms. So they have the exact same letters in them. So for example, 5 and 12. So two numbers that have no letters attached to them. They're like terms. Let's say A and 21A. So they have both 1A, so they are like terms, but they are not like terms with the first two terms. Other examples of like terms, so let's say 7ABC and 20CBA. They're like terms, even though the C, B, and A are written in different order in each of the terms. They each have 1A, 1B, and 1C. They have the same sequence of pronumerals, letters, therefore they are like terms. So let's look at some terms that are not like terms. So, for example, let's say 3A and 2P. They're not like terms, so you can't add them. Now that makes sense, Think of like A as an apple and P as a pineapple. If you had 3 apples and 2 pineapples, you wouldn't say you have 5 pineapples. That'd be crazy. So 3A plus 2P does not equal 5AP. In this case, we cannot simplify these terms. We cannot add them. We cannot simplify any further. Another example of terms that are not like terms, say 7 and 7C. So people get these wrong all the time. They think that if two terms have the same coefficient number in front of, they must be like terms, but that's not true. So 7 plus 7C cannot be simplified. 7 plus 7C doesn't equal 14C, and a lot of people make this mistake. Other examples of like term, let's say we had, of not like terms, minus 2x squared and 5x. Now these are not like terms. Even though there's an x in both of them and no other letter, x squared kind of means 2 x's. So the first one has 2 x's, whereas the second one has only 1 x. Therefore, they don't have the exact same sequence of pronumerals. So let's go ahead and look at actually adding or subtracting. So let's say we wanted to simplify this. So this is the same as collecting like terms. So we just want to write it in a simpler way. So what we have to do is identify the like terms. So this term and this term are like terms because they both have one y and that's all they have. So when we have to add or subtract them, we operate on the coefficients. We just add or subtract the coefficient. Remember, number in front of. We just do that. So 7 minus 10 is negative 3. So this equals negative 3y. Now the other two things are not like terms. So when they're not like terms, you leave them exactly as they were. Just like that. So this expression here cannot be simplified any further. That's all that we can do. Alright, let's look at multiplication and division now. Okay, so when you're multiplying and dividing terms, unlike for adding and subtracting, they don't need to be like terms, but just like we did when we were adding and subtracting, we just multiply or divide the coefficients. Now it says that we have to use index laws, and we do, but don't worry, none of them are complicated. This is just making sure that you know that, say, x times x equals x squared. So it's nothing too in-depth. So why can we multiply and divide? Well, that's because multiplication is actually just repeated addition. So let's say I have 7 times 4k or something like that. Now, you know that 7 and 4k are not like terms. So I could not add these together. But the reason that I can times them is because, as I said, multiplication is just adding something to itself a whole number of times. So 7 times 4k just means 4k added to itself 7 times. So of course we can add something to itself because every term, is the same as itself. So it'll definitely be a like term. So that's what 7 times 4k actually equals. Just 4k added to itself 7 times, 4 plus 4, blah, blah, blah. You add it all up, you get 28k. And that's exactly the same as what we would have got if we just multiplied the two coefficients together. Okay, so let's look at another example. So I'm going to rub this one off. Okay, so let's look at another example. So let's say I have 3x and I want to multiply that by 7xy. So multiply the coefficients. So 3 times 7 is 21. X times x is x squared. So that's what I meant by index laws. We don't write xx, we write x squared. And then there's also a y there as well. So let's say I had to do something like 20bc divided by 5. So in this case, I just go 20 divided by 5 is 4, and then I still have my BC. So again, I'm about to rub these off. Now what I wanted to show you as well was that sometimes what will happen is you'll get a division as a fraction and you'll need to simplify. So unfortunately, this involves fractions that you may not have done for a while. So when you have to simplify a fraction, you divide the top and bottom by the highest common factor. So let's look at an example of this. So let's say I have 20xyz divided by 15x. So the highest common factor is the highest thing that goes into both. So both of them have an x, so I can cancel an x. I'm dividing top and bottom by x. 20 and 15 have a common factor of 5. 5 goes into 15 3 times, goes into 20 4 times. And I'm just left with 4yz over 3. So let's look at another example. So let's say I have something like 22a squared b over 30ac. Okay, so it's the exact same process. So I've got to find common factors. So on the top, a squared, as I said before, it kind of means 2 a's. So we can get rid of that and get rid of an a on the bottom. 22 and 30 have a common factor. So 2 goes into 22 11 times, it goes into 30 15 times. So I'm just left with 11ab divided by 15c. Okay, it is okay to have a letter on the bottom of the fraction. All right, so now I'm going to change the screen again. So we're going to go through the distributive law. So where exactly do we get the distributive law from? So let's say I'm not a very good drawer, as you know, but let's say I have a bag of M&Ms and there are X M&Ms in that bag. And let's say I have another bag that also has X M&Ms. But then one of my friends, he thought, hey, he doesn't have enough M&Ms, so he gave me a few more. So let's say he gave me 3 more to go with this bag and 3 more to go with this bag. So how many M&Ms do I have? Well, here I have X, whatever X is, plus 3, and here I also have x plus 3. So, how many M&Ms I have is 2 lots of x plus 3. But what you also know is that I have 1x, 2x M&Ms, plus I also have 1, 2, 3, 4, 5, 6. So I've got 2x M&Ms plus I have 6 more. So these two things, this and this, are equal, and that's why expanding the brackets works as it does. So if I start off with something like this, the way that I expand the brackets, 2 times x gives me 2x, 2 times 3 gives me 6, and then we make sure that we get the sign right in the middle. So it was a positive times a positive, and that's why there's a plus sign there as well. So I'll show you another example of why the distributive law works as it does. So let's say that we have a couple of rectangles. So both of these rectangles here are the same size. Now we know that if they're the same size, they must have the same area. So what if I call the side lengths here A? It's the same. So I'm just going to call this b plus c. You know, if the side length was 4, I could easily find two numbers that add up to 4. So what I'm going to do in the other one, though, is I'm going to divide it up. So this one is still b plus c, but I can divide it like this. So I have divided the bottom area into two rectangles. It still has the same area. So the area of the top one is a times b plus c, length times width. So for the bottom one, the area of the whole rectangle, the whole way around, is going to be the area of this rectangle plus the area of this rectangle. So the area of the first rectangle is just a times b, the area of the second one is a times c. So therefore, the area of the bottom rectangle is AB, a times b plus a times c. But they have to be the same area. This has to equal this. And that's how we get the distributive law. A times b plus c equals a times b plus a times c. Remember, to expand brackets, you distribute the thing outside of the brackets to everything inside the brackets, and just watch your sign there. So let's go through a couple of quick examples. You probably do remember this. So 3 times by x minus 5. So we go 3 times x. 3 times 5 is 15. Now because it was a positive times a negative, I need to put a negative in there as well. Let's say 2x times by 4x minus 9. Same thing. 2x times 4x, that gives us 8x squared. And then 2x times negative 9 will be negative 18x. Because 2 times 9 is 18, and a positive times a negative is a negative. Alright, sometimes you will have more than two things inside the brackets. So let's say I have a outside of 7y plus 2 minus a. So we do that a similar way. We distribute what's outside the brackets to everything inside the brackets. So 7ay plus 2a minus a squared. Sometimes you'll have a negative outside the brackets. So I have a negative 5x and I want to multiply it by y minus x, for example. So 5x times y, but it's a negative times a positive, so the answer is negative. 5x times x gives 5x squared. Because it was a negative times a negative, answer positive. Okay? Fantastic. So I'm just going to rub them out and show you one more type of example. So sometimes you'll have to expand like two brackets at once. So you might get something like 3x minus 3 plus 7 times 4x minus 5. Just expand each one individually. Remember, we always do brackets first. So I have to do this first, then this, and then I add them together. So 3 side of x minus 3, so 3x minus 9. Distribute the 7 to everything in the brackets, so I get plus 28x minus 35. Now I need to collect like terms. 3x plus 28x is 31x. Minus 9 minus 35 is negative 44. And we cannot simplify this any further because 31x and 44 are not like terms. Hope you've enjoyed the video. Sorry it was a bit long. This has been the luckiest maths teacher in the world. Have a great day.